Hello world, I'm Kostas Sinolakis. I'm a professor of civil engineering at the University of Southern California, also a member of the Academy of Athens. I want to talk to you about my personal experiences in Tοχόκου with the perspective that I have gained with 29 years experience in field work and studying tsunamis. The basic lessons, in my view, that we've learned from Tοχόκου that we should have known are to always consider the worst-case scenario when preparing evacuation maps and designing infrastructure. To avoid bagatellomania, trifle worship, always think of the big picture. How important it is to have tsunami hydrographs, which means to have some way of knowing how fast the tsunami flood will rise, so we'll be able to inform people. Last, we've learned that large-scale structures, vortices, can set up outside ports and they can interrupt shipping for days. But let me start. What happens when you ignore the worst-case scenario? And I put together some cases from the last decade. First of all, think of the Korean Seawall, the Korean ferry that sank in calm waters. Think of Malaysia 370 that we're still looking for. Think of the fiasco with the 737-800 MAX. And of course, think of Fukushima. The common thread in all of these is that people did not think of the worst-case scenario. In terms of tsunami hydrodynamics, what you can see in this figure is all the projections across the Pacific Ocean of the evolving tsunami. As it turns out, numerical codes, state-of-the-art numerical codes, do a fantastic job in predicting the evolution of the tsunami in the far field. The real challenge remains what we do in the near field when the tsunami arrives within 30 minutes or less. And it is exactly there that we need to be extra vigilant. In this sense, in thinking about the worst-case scenario, I saw in this map the information that had been available since the 70s about large earthquakes that could strike Japan. All of this, apparently, was ignored in the design both of the Fukushima nuclear power plant but also of the evacuation maps in the Sendai Plain. And as a result, tens of thousands died. In this table, you can see in a little bit more detail what the estimated magnitudes of these historic earthquakes were, again, from the information that we knew in 1974, starting from the 1869 Jogan tsunami, with an estimated magnitude of 8.6. We did have evidence before 2011 that really large earthquakes could strike that region. Well, in that regard, the catastrophe in Fukushima and in the entire Sendai Plain was avoidable. If you look at the slide, which comes from TEPCO, the Tokyo Electric Power Company that was operating the Fukushima nuclear power plant, what you can see is that they had estimated a maximum water level of 4.4 meters. To give you an idea of how incomprehensible this is to any bona fide tsunami scientist, almost every year, somewhere around the world, if not every year, every couple of years, we get a tsunami with a height of about 4.4 meters height, I mean the maximum elevation the tsunami rises on land. How could it be that in Japan, which gave to the world the name tsunami, the worst-case scenario for a nuclear power plant right on the coast was a 4.4 meter wave, which incidentally was quite similar, the design wave, to what was perceived in that location during the 1960 Great Chilean earthquake. So here we have the almost impossible analysis that puts the wave at the power plant from a local earthquake at the same size as the wave from an earthquake that takes place in Chile. Defeats common sense. Again, a case of the engineers not thinking of the worst-case scenario. Another part is the location of the emergency power generators. Let me remind you that there were two aspects of the disaster in Japan. One was the humanitarian toll of 18,000 plus people, which we still mourn, but still that's a small number compared to the 240 who died in the Indian Ocean tsunami in 2004. The other aspect of the disaster was, again, the accident at the Fukushima nuclear power plant. And even if the analysis, the engineering analysis about the maximum wave was faulty, how can one excuse the fact that the emergency diesel generators, which are the backup power for the nuclear power plant, were mostly located on basements, which means even with a small flood, they would flood and they would be rendered useless. The sequence of events that took place is that the earthquake happens, triggers shut off of the, or scramming down of the nuclear power plant. There is no power. The diesel power generators kick in. They get flooded by the tsunami. They stop operating, all in Fukushima nuclear power plant 2 except one. So the plant had to rely on battery power, which only lasted for about 6 to 7 hours. By that evening, the plant was without power, and apparently the reactor had already started melting. This was entirely avoidable. But what also happens when you avoid the worst-case scenario? Here is the picture of a gymnasium in a school about 20 kilometers south of Sendai. What happened here is particularly tragic. The school was located outside the area that the evacuation maps had anticipated. When the earthquake hits, the students and the faculty, they move out, exactly as they're supposed to. Then they hear the tsunami sirens. Then they go back in. Aftershocks happen, the students move out again. And then there is confusion. They hear again the tsunami sirens. What are they supposed to do? Are they supposed to wait outside and protect themselves from the earthquake, or are they supposed to go back in the building, evacuate at least to what in Japan is the first floor, what in the US is the second floor? What happened is about half of the students with their teachers stayed outside, about half went to higher ground. The students who stayed outside, tragically, they all died, and these are their personal items. We never want to see something like this again. I will end by showing you this, which is at least that we gained something from Tοχόκου, and this is the first tsunami hydrograph. What this shows us is how quickly the water level rises. And as you see here, that within a period of about 10 minutes, the water level has risen to about 10 to 12 meters. That's about 30 to 40 feet. That's within a period of 10 minutes, which goes to tell you how quickly one needs to evacuate after a tsunami. Last, I'll show here the big vortex that formed outside of Ori, which triggered a lot of work, at least in the United States, PhD thesis by Nikos Kaligeris, to try to understand how these vortices happen and how do they affect ports. Ending, I want to always tell you that in terms of thinking of the worst, we should always remember that we exist on Earth because the dinosaurs don't. Thank you very much.